Hello everybody, what I thought I'd do is do a presentation on applications of trigonometry. Now this specifically relates to exercise 3I in your textbook, although most of the textbook exercises do have a couple of practical application questions at the end of them. So I guess it relates to a number of the exercises that run through chapter 3. Alright, so let's try this one in particular. Alright, a 7-metre long ladder is leaned against a wall. The foot of the ladder makes an angle of 42 degrees with the ground. How high does the ladder reach up the wall? Well, if we draw a quick diagram, so there's my wall, there's the ladder, and we know the ladder is 7 metres long. And we know the foot of the ladder makes an angle of 42 degrees with the ground. So this angle down here is 42 degrees. How far does the ladder reach up the wall? So there we go there. That's what we want to find. We want to find x. How high the ladder reaches up the wall. Right, let's mark in all the things we know. Well, here's the reference angle. We want to know this side here, which is the opposite side because it's straight across from the reference angle. Let's hope we have a right angle here, so our wall stands up straight. After that, we've got a hypotenuse. The hypotenuse is straight across from the right angle, and next to the reference angle is the adjacent side. So we want to find out the opposite side, and we know the hypotenuse. So let's see here. The formula we should use is sine of theta is equal to the opposite divided by the hypotenuse, because we want to figure out the opposite side and we know the hypotenuse. No other formula involves the opposite and the hypotenuse. So let's continue by putting in all the things we know. In place of sine goes 42. In place of the opposite goes x, and in place of the hypotenuse goes 7. Now let's see, what we need is x on its own, so what I'll do is I'll times by 7 on both sides. Now that 7 will cancel out with that 7 because this is divided by 7 and times by 7, they're opposites, and so she'll cancel out. So we'll have x is equal to 7 times by sine 42. And when you put that into your calculator and work it out, you should find that it's equal to 4.683 meters. Now, if we round to 2 decimal places as we should, now let's see. Well, since that's only a 3 and here are our 2 decimal places, this should be 4.68. And that's the height the ladder reaches up the wall. So the height it reaches up the wall is 4.68 meters. Alrighty, let's try another one. Okay, a 3.4 meter tall TV antenna is held in place by a cable that has an angle of 35 degrees above the ground. How long is the cable? Well, again, if we draw a quick diagram, so here's my ground, and here's the cable, and here's the TV antenna. There's my TV antenna, and now there's a cable holding it in place here. And let's hope our TV antenna is at right angles to the ground, otherwise it might not be straight for very long. It has an angle of 53 degrees, and we know that the TV antenna is 3.4 meters tall. And we want to know how long is the cable. So we'll call that x. So here's the cable. Alrighty, so reference angle here, straight across from the reference angle is the opposite side. Right next to the reference angle is the adjacent side, and straight across from the right angle is the hypotenuse. Okay, so the opposite we know, and the hypotenuse we want to know. Alright, well I think that's going to be sine of theta. Sine is the opposite divided by the hypotenuse. So sine is equal to 53 degrees. Now the opposite side is 3.4 and the hypotenuse we don't know and we'll call that x. Now what can we do? We need this x off the bottom. What about if we times by x on both sides? Now if we times by x on both sides, we end up with divide by x times by x. Now they're opposites and they'll cancel out, and that will leave us with 3.4 on the right hand side. Now x times by sine of 53. Now what I'll do is, to get rid of this times by sine of 53, I'll divide by sine of 53 on both sides. So that will cancel out with that, because times by sine of 53 divided by sine of 53 is the opposite. Now 3.4 divided by sine of 53. If you put that into your graphic calculator or your sketch or your script calculator on your iPad, you should find that x is equal to 4.284 meters, which we can round to 4.25 meters. Right, and another statement here, the length of the cable is 4.25 meters, might also help. I'm not quite sure I have room here, but it's usually a good idea to make a statement about what you're finding if you have an applications question like this. Last one. Okay, a playground slide of length 4 meters has a height of 2.4 meters. What angle does the slide make with the ground? So again, if we draw a little diagram here, here's our slide, there's the ladder going up, and here's the ground. Let's hope our ladder is vertical. Now, let's see, the length of the slide is 4 meters. So from the top to the bottom, 4 meters, and the height is 2.4. What angle does the slide make with the ground? Well, there's the angle in there, and we want to figure out this reference angle here. Alright, so let's see. From this angle here, there's our reference angle. Straight across is the opposite side. Straight across from the right angle is the hypotenuse, and right next to the reference angle is the adjacent side. Now, we have the opposite side and we have the hypotenuse, and what we want to know is the reference angle. So what trigonometric ratio, sine, cos or tan, involves the opposite and the hypotenuse? Well, sine of theta. Now when we plug in all the things we know in place of the reference angle, well, we don't know that yet, so we'll just leave it as theta. The opposite is 2.4 and the hypotenuse is 4. Now what I'll do is I need to get rid of the sign, so the opposite of sine is inverse sine. And I'll do that thing to both sides. I'll make each side take the inverse of it. Now when I do that, inverse sine and sine, they're opposites and cancel out, and just leave theta. And when you do inverse sine of 2.4 divided by 4, what you should find is you get 46.468 degrees, and we'll round that to 2 decimal places and say, well, that's 46.47 degrees. Alrighty, so remember, this is all to do with 3i. Have a go at 3i. Tell me if you run into any problems, and I'll see you in class.